Hello, and welcome to the first of Humanizing Autonomy's Future of Behavior AI series. I'm Kim Vigilia. Today is the first of 4 episodes dedicated to exploring the future of behavior-based artificial intelligence. Nowadays, AI is so widespread that the term on its own sometimes doesn't mean anything anymore. And deep learning or machine learning is so complex that it's hard to separate hype articles from a more technically grounded, realistic perspective. That's why in the next 30 minutes or so, we want to take you through an overview of what we mean by behavior AI, both on a business level and a more technical perspective. We'll discuss what this technology can and can't do, how it's different than current deep learning models, and what we need to know about bias, ethics, and limitations in delivering the model. So today you'll hear from the Humanizing Autonomy team. We're a growing behavior AI company based in London looking to change and improve the relationship between people and automated machines. Our next episode will feature companies already using behavior AI in the automotive and lifestyle sectors. So across the series, you'll get a well-rounded perspective on the technology and how it could be applied to virtually any sector. All sessions will be bite-sized, educational, and top-level. So let's begin. I am pleased to introduce Maya Pindeus, CEO and co-founder of Humanizing Autonomy. Maya envisions a world in which technology is built around people and has a positive impact on humans and society. She's an architect, designer, and engineer with degrees from Imperial College London and the Royal College of Art, and has a deep passion for human-machine interactions. A leading founder in AI, she is a Forbes 30 Under 30 awardee, contributes to the World Economic Forum, and recently won Amazon Web Services 2022 Startup Founder of the Year Award. Maya, welcome.
Thanks so much, Kim. Hi, everyone. We're super excited to launch this educational series on behavior AI technology. So before Dominic shares the more technical point of view of this AI platform, I wanted to provide some context on how the journey began, how we're developing this technology, and why it is so important for our world today. While studying the future of automation, my co-founders, Leslie Nuteboom, Runak Bose, and I were really surprised to discover that a key part of the tech development equation was missing, and that was people. So we asked ourselves, how could the development of automation know so little about the people with which these machines were supposed to interact? Of course, the answer is very long, complex, and layered. And I do apologize, a bit of a history lesson as well, but I'll try to give a summary. Over the last few decades, there was a clear shift to machines designed for other machines. And this grew in direct correlation with technological advancements and the popularity of movements that I'm sure you're all familiar with, like the Internet of Things or IoT, as you might know it. Coined in 1999 by Kevin Ashton, MIT's executive director of Auto ID Labs, IoT today refers to the giant collective network of connected devices and the communication between these devices across the internet and other networks. IoT was meant to simplify our lives as people, but one of the side effects is that it also made it completely normal for machines to speak only with other machines, without or with very, very limited human interaction and feedback. But even before IoT or machine-to-machine concepts, there was already a precedent set for design thinking shifting away from people as a result of the introduction of machines. You can see this very clearly in the evolution of urban city planning. Ancient cities were people-centric. They were commonly designed to protect and uphold citizen life, to sustain healthy conditions for people, and to encourage social community. That's why you see a lot of these old towns centered within fortresses, within walking distances of public spaces, such as markets, cathedrals, and squares. Furthermore, roads, buildings, and pavements, even distances to public spaces, were measured in context to the size of humans. Maybe also horses, but primarily with people in mind. And this changed drastically with the introduction of machines, such as the motor vehicle. Combined with the increase in number of people living in urban areas, And suddenly you have these massive, expansive cities, this urban sprawl, seen more frequently in the Americas, such as in the United States, as these are younger countries, where the design of modern urban planning has shifted away from people and focused more on distances, on where the car can take us, where the car can go. So as a society, we have been shifting away from people-centric concepts, people-centric design for over a century, which is why it really is not a total surprise that so many autonomous technologies do not really consider the human as a natural relational stimulus. For years, most technologies are designed with the human placed as a catalyst for a series of automations. It's not actually responding to us as a person, it's responding to a specific action we have been taught to do. Let me give you a few examples. If I want to dry my hands in a restroom, I must find the sensor on the wall and the hand dryer and wave until it recognizes me. And there's this delayed and slightly awkward reaction and frustration if the machine is not recognizing me as a person. If I want, for instance, go shopping and use a self-checkout line at a grocery store, I must adhere to the tight limitations, a tight window that the machine gives me. If the machine cannot see, I've put the groceries on the wrong side of the device, or it freezes until it recognizes where the purchased items have been added. A lot of frustration. Or if I'm driving a vehicle and you get this little beep sound, this alert, when something is too close to the car, it is not because there's a person walking next to it. It is because the car has sensed a physical object near it, but it doesn't really know if it is a small child, a garbage bin, or a cat. There's no human context, and that alert recognizes a garbage bin the same as a small child. So if we're going back to the start of the story, Leslie Runeck and I changed our question. Instead of wondering why autonomous technology focused so little on natural human behavior, we shifted instead to how can we make technology more people-centric? Fortunately, there is a continuous and growing movement towards going back to human-centric design and technology. And there's a demand for ethical technology that doesn't just simplify human life, but also protects and sustains it. And behavior AI is part of that. Behavior AI, as you'll hear in much more depth from Dominic, considers the physical behavior of people and teaches these patterns to machines so that they are better equipped to respond with a relevant action and not just a serious if A then B or B then C logic. Instead, the algorithms used are designed to help the machine consider the person's context within each situation and within a large variety of situations. And because behavior AI is based on cameras and video footage, it is similar to how a person would see and assess a situation visually. What can you tell about how a person is standing, walking, or moving? And what does it say about the situation? Are they running for a bus? Are they leaning away from you? Are they going to slip off the pavement? With this technology, combining computer vision with behavioral psychology, deep learning, and statistical AI, we'll be able to help so many people when it comes to safety and productivity, customer experience, and ultimately make human-machine interactions more pleasant and better for people. I'd like to give you a few examples of what this could mean. Number one is better physical safety. The machine or whichever product your company uses can see and assess what is happening in a certain situation. This is particularly important in the mobility space, automotive and driver assistance applications, where a certain 360 visibility is important and required for road safety. It could also mean a lot for the manufacturing, construction, and last mile delivery industries, who rely on automated machinery in hazardous environments. It could mean better customer experience, because the machine can understand your body place and your position, your actions, and it can understand if you're engaged, if you're distracted. It can predict what will happen next, which direction or which action are you planning to do next. This is super critical in anything from city planning, retail, advertising, for out-of-home experiential events, where you want to really understand the analytics of where and how people move and act and interact. And at a very top level, behavior AI will be a key differentiator in creative simulations, mixed and augmented realities, and in developing digital twins, where real human behavior is required to generate realistic products and simulations. Essentially, if we boil it down, where there's a camera, there's a potential to improve, to be better. And where there are lots of people interacting with machines, with the capability of camera vision, whether a vehicle, a traffic light, a coffee machine, or even a video game, we believe that behavior AI will also change the relationship we have with automated technology. It really is about encouraging trust and, as a result, adoption. Dominic will also dive into how it is possible to do all of this ethically and safely for people and individual privacy, because ultimately it's all about having the people at heart. And with that, I pass it back to Kim and Dominic. Thank you so much for listening.
Thanks, Maya, for that background and very cool history. I'd like to now introduce Dominic Noy, Principal Behavioral Data Scientist at Humanizing Autonomy. Dominic's been a driving force behind the company's behavior prediction technology, with particular interest in the company's efforts to boost the interpretability of its underlying predictive models. He holds a PhD in experimental psychology, psychophysics, cognitive modeling, human-computer interaction, a master's in statistics, and a master's in psychology, psychology of action. Dominic, welcome.
Hi, everyone. So as Kim mentioned, I'm Dominic Noy. Thank you, Kim and Maya, for this nice introduction. So today I would like to give a brief overview of deep learning for behavior AI, starting with what is behavior AI, how is deep learning applied or related to behavior AI, and then I will provide an overview of its current limitations and what to look out for. And finally, introduce you to the potential of behavior AI as a technology that is a better model. So first, I'd like to start with the story of Icarus, who flew too close to the sun. So I'm not the best storyteller usually, but let me take this as an analogy and that I will try my best. So Icarus was the son of Daedalus, the creator of the maze or the labyrinth. And to escape their imprisonment, Daedalus built two sets of wings for himself and Icarus. So both were made out of feathers and wax. And Daedalus tells Icarus to fly a middle course, not too high where the sun could melt the wax, not too low where the waves could wet the wings and pull him down. However, that's a problem. Drunk with his new power of flight, Icarus immediately soars towards the sun, which begins to melt the wax and his wings, resulting in the feathers to fall off and causing him to fall to the ocean and drown. So the myth reflects on subconscious truths, and this is why I'm telling you that. Overconfidence can be a dangerous and potentially fatal commodity when transitioned from adolescence to adulthood. And I like to use it as an analogy to the applications and capabilities of current AI technologies. The premature use of overconfident AI systems can be unethical and dangerous when applied to human behavior. Earlier, Maya said that behavior AI considers the physical behavior of people and teaches these patterns to machines so that they are better equipped to respond with the relevant actions. So now I would like to build on this and like to define behavior AI as any AI system which directly interacts with humans or needs to understand human behavior for further decision making. So when we talk about behavior AI, we mean that we model human behavior using artificial intelligence systems. Kind of pretty obvious, but we model human behavior because we build machines that either directly interact with humans. So we need systems that make decisions online in real time. An example is an autonomous vehicle has to decide within milliseconds if deceleration is appropriate to communicate yielding to a pedestrian or to accelerate. Or we build machines to understand behavior offline for subsequent decision making. For example, from videos, we estimate how many people were engaged with an advertisement, how many people crossed the street while being distracted, or we assess the risk for injury on a construction site by analyzing the worker's behavior. So to build such behavior AI systems, they need to be ethical, to avoid discriminating any individuals based on anything else than their concrete observable behavior. They need to be safe. And those systems should be designed in a human-centric way meaning that humans can interact with those systems intuitively and naturally. There has been a recent hype to use end-to-end deep learning for modeling human behavior. So I think it started around 2012. And deep learning can theoretically approximate any pattern when sufficient data is provided. So they're very hyped because you can solve complex problems without requiring a profound understanding of the mechanisms underlying the problem. In tasks like language translation, for example, or object detection and images, it outperforms other machine learning algorithms by a huge margin. And it is also applied to understand, so recently it's also applied to understand and predict human behavior, whether it's about predicting pedestrian crossing, as I mentioned before, for autonomous vehicle applications, building chatbots as customer service, or to evaluate facial expressions to understand, for example, the mood of the customers, just to name a few application areas. So the problem is when applying deep learning to behavior data, there are several obstacles, risks, and limitations that we need to consider, and that are very important. And we categorize those limitations into three major pillars. The first one is related to the model size, the data quality, and transparency. The second one is related to the fact that most machine learning methods match statistical patterns, but lack a notion of cause and effect. And the third one is related to the lack of a notion of uncertainty when we are predicting on examples that are out of the distribution, so out of the training set that we use to develop the model. I mean, of course, all of those models, their solutions, they are related. And its distinction is somewhat artificial, but I think it really helps now to illustrate how we can address some of those limitations. So deep learning models are considered black boxes. You might have heard of this before, because the mechanism that transform the input into the output is obfuscated by an imaginary box. You can think about a black box around a pedestrian, for example. So this is mainly because of the huge amount of parameters and nonlinear activation functions in those models. And so the decision-making of those systems is not really transparent for us humans. And transparency facilitates accountability, and we need to know who holds responsibility for any decision that is based on the model output. So in order to circumvent this, we can build models in a modular manner, for example. We can use deep learning to extract interpretable features that we identified as relevant through our behavior studies. And those features can then be combined within smaller probabilistic models. So as an analogy, we use deep learning as our ears, eyes, and nose to process sensory information. And then the heavy lifting, the reasoning, the symbol manipulation, the stuff that is conscious to us, is performed by areas mostly in the prefrontal cortex. So this is in our behavior AI model, done by probabilistic models. For example, we extract information about the pedestrian, like the body orientation, the gaze behavior, distances, hand motion, etc. And we extract this separately for different deep learning models, and then build individual modules for intention to cross, the risk perception, vehicle awareness, and other psychological constructs. And those modules are then further combined with probabilistic models that are easier to handle in order to predict if the pedestrian is going to cross in front of the vehicle. The next limitation is most machine learning methods, including deep learning, match pattern based on statistical relations. They don't have any understanding of cause and effect. So causality means that we can quantify how much one event contributes to the state of another event. And if you want to trust the model for decision making, they should make causal sense, or actually a lot can go wrong. So for example, if you train a deep learning model on pedestrian crossing data for steering an autonomous vehicle, you might end up with a model predicting pedestrians won't cross when the vehicle accelerates, because this is what the data actually tells us. Another example, or the deep learning model might learn that children are more careful crossers than adults, but this is so because they are usually accompanied by more careful parents, and not because the children are more careful crossers per day, right? So the lack of notion of cause and effect is also the main reason why those models are biased. And if trained on such data, as you can see here in this example, so if you train deep learning on such data and you have a lot of it, ice cream sales would predict sunburn. And a straightforward way to deal with this problem is to build models that allow us to use our human expert knowledge to specify causal relationships directly into the model, as you can see in this example by those arrows here. And the problem is, however, those models, which are called Bayesian networks, are only causal in case we have really good grounds to believe that causal relationships that we assume are correct. So this means that we need to understand our problem at hand really, really, really well. And finally, last limitation, there are so many ways people can look and behave before crossing the street, boarding a bus, acting on a construction site, etc. So there's no way that we can cover all the different edge cases and relevant scenarios with the data set used for developing the model. So we cannot ensure that a model trained on a particular data set generalized to other scenarios. And probably many have heard of this before. So the thing is, we claim that a notion of uncertainty that for behavior that the model hasn't seen before is as important as the prediction itself. And we humans have this capability. So model uncertainty for out of distribution examples can be obtained by following a probabilistic or a Bayesian approach to estimate the distribution over parameters of the model and over the model itself. So by following a Bayesian approach, you can obtain such uncertainty region for the decision boundary, as you can see here on the right side of this, in the right image. And this is what behavior AI has to consider. So to be ethical, safe, and human-centric, behavior AI must be transparent, must understand cause and effect, and must have a notion of its own prediction uncertainty. If those capabilities are not addressed, we might follow a similar tragedy as Icarus. Thanks.
Thanks, Dominic, for that great overview. And it's a really good segue point to our fireside chat. So first question I have is around one of the challenges that the AI and deep learning community continue to grapple with. And that's with the direct and indirect bias of algorithms. So can you talk more about how bias is created in deep learning and how developers can prevent as much bias as possible during their build phase?
Right. So the word bias is actually pretty complex and can have very different meanings. And it's also not necessarily negative. But when the media refers to biased algorithm, it usually means that models make predictions based on certain attributes that we are not aware of and that we consider as inappropriate. For example, a very popular online advertising service showed ads for high-paying jobs more often to men than to women. And it also showed ads for criminal background checks more often to Black than to white men. Mm-hmm. People in general. So this is called unfair bias, and exists because deep learning systems match statistical patterns in data, as I mentioned before, and those systems don't have any notion of cause and effect. So it's a bit it's related to the previous presentation. So ways to reduce such bias are to control for all the confounding variables explicitly that we actually care about, to choose the training data carefully. So for example, sample data that best represents actually a population of interest. And this, surprisingly, this is rarely done. Usually we take all the data that we get in order to get our deep learning models working. So don't rely on deep learning alone, and also try to build causal models and use expert knowledge from the field to specify the model structure. And then extract meaningful features separately. This is how I explained what we do for the pedestrian use case. So extract meaningful features separately to represent certain attributes and then combine them in smaller interpretable models. And last one, maybe focus on concrete behavior attributes and less on the visual attributes. I think Maya mentioned this before. So don't focus on clothing and gender and age and things like that, but look at the concrete behavior of the person.
Yeah, and you're right to remind us of the different kinds of bias. So unfair bias, as you explained it, it's raised the profile of how problematic uncontrolled or thoughtless technology is. On the same line, ethical AI is also much talked about, but sometimes the definition changes depending on who benefits from it. So how do you define and prove an AI is ethical on a technical level?
Mm-hmm. I think so. It's pretty close to the previous question. I think AI systems that are considered unethical are usually systems that predict when the prediction is affected by attributes of the data that are not related to the problem at hand. And that are considered as inappropriate, as I was saying before. So this is the unfair bias, and it's very much related to previous question. Those attributes can be gender, income, as I said, maybe race, religious beliefs, sexual orientation, etc. However, what is considered as inappropriate is culture specific and should depend apparently on ethical committees, the government, and everyone who's interacting with the technology, so our society. And it certainly shouldn't depend only on tech companies, what is a current practice. And as mentioned, there are ways to reduce such unfair bias to make the systems more ethical. But when we think about deep learning, by definition, end-to-end deep learning systems will be biased in some way or the other when applied to behavioral data, because it's impossible to control for all the confounding variables. So to understand if a deep learning system makes unethical decisions, I guess there's no way around it than rigorous and continuous testing of diverse data sets in all the different imaginable conditions. However, a system that is truly ethical is, in my opinion, and this is close to my presentation, is, in my opinion, a system that has a notion of cause and effect and is aware of its limitations and prediction uncertainty. Only those systems can actually, in the end of the day, can be safe and therefore ethically reasonable.
Yeah. And I think that's a fair statement about any technology, right? To make sure it's honest in its own limitation. So you've been clear that the insight we can extract from AI is imperfect or incomplete without context. Can you talk more about that?
Right. Okay. So when I ask you to rate how happy I am right now, and you only see my facial expressions, you might say, "Oh, Dominic is extremely happy because he's smiling." Okay, now I'm smiling a bit more than usual, but
because you're talking
to make my point clear. But if you knew that I'm currently in a Q&A session, the same smile could be interpreted as nervousness or an attempt to be liked by the audience. So now that imagine that the two of us had a discussion before this webinar, then you probably would interpret my smile as fake, right? So what you need to understand, what we need to understand my true intentions and feelings from the observable behavior, like my facial expressions, is actually the context. And theoretically, deep learning can account for this sufficiently. So if sufficient and diverse data is provided, but how do we really know that it does? Only through systematic and thorough testing. And there are simpler ways. I mean, the simpler way is to build more transparent models and identify the relevant context variables and to explicitly consider those variables in the model. So I just want to mention that we don't do facial recognition, but for such use cases, we consider the actual behavior, what people are actually doing, the context, and certain facial movements to detect the overall mood of people. Just as an example.
Yeah, that's a good point. That it's not facial recognition; it's the movement. But Dominic, I was saying, if you're smiling, I'm assuming it's because you're talking to me. But actually, that makes me think of the recent news of Lambda. So if you hadn't caught it, a few weeks ago, chatbot model made headline waves because one of the engineers, and it's a Google AI engineer, had become sentient and could perceive and feel emotions like a human. So love your opinion on this. A, is it possible? Is that even technically possible? B, where do you draw the line between the sci-fi hype and the reality behind teaching machines human behavior?
So what I saw is that the output of Lambda is actually pretty impressive. However, claiming that we have AI that could perceive and feel emotions like humans means that we are able to build machines that are conscious of the feelings. And as far as I am aware, we don't have even a good and clear definition, and we are not agreeing on what consciously actually means in the first place. So the claim of Lambda being sentient was also already denied by Google and Popular and many other scientists. So I'm not an expert to answer how far we are away from sentient AI. However, for me, it actually looks pretty far, since the most advanced language models, including Lambda, are using deep learning, and in particular transformers, so differentiable models. And those models don't have any notion of cause, effect, and uncertainty, which are functions that seem to me pretty relevant to simulate human-like cognition. So something else that I have to mention is that it's very dangerous to overhype those systems when applied. As can be seen by many accidents in the autonomous vehicle space, where drivers were over-relying on the capabilities of the technology. There are also attempts to create chatbots that function as therapists. So those systems start to enter our emotional and psychological world to understand if we are happy or sad or depressed, and they provide recommendations. So the risk related to those applications are huge, right? There's a very popular case when a chatbot learned to spread Nazi propaganda or anti-feminist content. And now imagine that a bot would consult a borderline patient. So this combined with the human tendency to anthropomorphize everything, any object, is very dangerous. Thus, when we create systems that interact with humans, we have to be aware and really realistic about what we can expect from them.
Yeah, I think I remember that in the news as well, and quite dangerous, as you say, when it enters something that will directly impact us as people. I guess we'll have to see what happens, what else happens. But the last question from me was around the training models. So you mentioned deep learning models. They obviously require a lot of data in order to improve and learn. So Gartner had predicted by 2024, 60% of the data used for development of AI and analytics projects will be synthetically generated. So are there any pros or dangers of using too much of the synthetic data?
Okay. I'm not the expert on data synthesization. However, I can see why this makes sense, and why many companies are comfortable with this. So first, it addresses privacy concerns, right? So if you want to work on data while maintaining privacy, we theoretically we can build a generative model, fit on the data, and then generate new data from this generative model, generate new artificial data. So like this, we could maintain the privacy. Another reason is that it circumvents labor-intensive. It circumvents labor-intensive data labeling. So most of today's deep learning models that are applied in industry are supervised, meaning that we need humans to annotate the data, right? And by generating new data, we don't need to label because we already know the ground truth in advance. And then a third thing, and you already mentioned that, is it is believed that synthesizing data might help generalizing to new situations where that weren't presented in the original data set. And therefore, we are able to deal with out-of-distribution examples and edge cases. And while I buy the first argument, so the data privacy argument, I have my concerns with the other two, particularly when applied to complex behavioral and motion data. The synthesized data quality depends on the data on which the model was trained, right? So if the original data is biased, the model trained on synthesized data will probably be biased as well. Plus, we are probably not able to synthesize easily behavioral data that is far from the distribution of our training data. So I expect that we certainly missed out many real-life situations. Although I can see some benefits, data synthesization for behavioral data should only be considered as a complement. So I think very importantly, if I still have the time, I'm slightly afraid that the hype around data synthesization distracts from other essential but more boring solutions to obtain representative data sets, which is related to data collection strategies, representative data sampling, data labeling, and the entire data quality assurance process. So I hope this hype won't distract so much from those very essential, important practices. I would always ask the company that synthesize data for their specific reasons. So what kind of problems do you want to solve with synthesized data in the first place? There might be some much simpler solutions to your data problem, actually. And was the data collection or labeling process too expensive? Is that the reason? So building a model to synthesize data might actually take more resources and time than just collecting data and labeling it. And finally, we can't deal with edge cases why can't we do it in a more explicit manner? Yeah.
Just maybe a short question. What's one fascinating trend you've seen from human behavior? I guess just trends in human behavior that you've seen.
Okay, very quick. That nowadays there are psychologists and other related disciplines that actually become relevant to develop machine learning models and also for the application. So it's getting much more interdisciplinary. I think I really like that.
How lawmakers and regulators should look at that notion of the uncertainty from a machine. That would not increase the notion of risk, even though that machine might be safer than a machine that does not have this notion. I have a think, but if there's any that you want to answer right now very quickly, or if we can record it after.
Okay, very quickly about the uncertainty. So I'm not sure if I'm answering that correctly, but we as humans, when we drive and it's getting dark and rainy and it's very crowded, we have a notion of uncertainty. I mean, there are also a lot of studies showing that this is probably that we do similar Bayesian inference in order to have that than what we are trying to implement in machines. So the idea is that when we have an autonomous vehicle and that drives through downtown and it gets very messy, that this system also has a similar notion to slow down. So it's not always about to predict accurately if a pedestrian is going to cross. It's about understanding when those kind of predictions are getting uncertain. And the Bayesian approach isn't the best solution. To me, it's right now, it's the best solution that we have. So I don't want to say that it can solve all the problems, but it's at least the right way we are going into. Do I have more time?
Just one more minute.
Okay, then you ask another question, I think, about what we should tell to business leaders, right? What they have to care about. So I think the first thing is, how did the AI providers obtain the data for model training and evaluation in the first place? I mean, this is pretty obvious. So how was the model evaluated? It's very important, right? But this is also obvious. So I think very importantly, what I very quickly want to mention is that any performance measure can look satisfying if you don't know exactly what kind of data was considered. So for example, it's easy to build a pedestrian crossing prediction model that does a pretty good job and predicts 99% correctly if a pedestrian is going to cross or not. But the thing is that if you consider all the detected pedestrians in the image, this is easy because most pedestrians are walking somewhere far away from the vehicle and they are not really relevant. And of course, most follow their current path. So it's easy to make those kind of predictions. So when considering all pedestrians in the image, we can easily obtain very high prediction accuracies with very simple linear models. We don't need deep learning for that. So it's important to evaluate the model for the specific, relevant, and very, very difficult cases. And usually what I see is that companies just present some overall evaluation spreadsheets without explaining how the data was selected for evaluation in the first place. So this is really important to ask. Yeah, I think time's running out, right?
Yeah. But Dominic, thank you very much for your insight, and thanks for joining us. And thank you, Maya, for joining us earlier as well. So that's it for today. We hope you enjoyed it. And we hope you come back. So please join us for the next episode, which runs in September. And that's going to focus on real case studies where behavior AI is successfully being used. We'll interview customers from across automotive, connected home, and other industries. So please do join us. We'll jump more into detail there. If you're not already connected with us, please follow Humanizing Autonomy on LinkedIn and Twitter, subscribe to our newsletter, or email us at the info@there for any questions. Finally, we'd love your feedback. We're continuing to do this, create educational content like this. So please complete the survey that will pop up at the end of the session, and we'll try and get your feedback in. Until next time, from the team at Humanizing Autonomy, thank you, have a great day, and goodbye.